Welcome. In this video, we'll explore three fundamental statistical tests: t-tests, ANOVA, and chi-square tests. Our goal is to understand when to use each test to analyze data effectively. At their core, all three tests are about comparing groups. However, they differ in what they compare and how they do it. Think of them as different tools in a toolbox, each designed for a specific type of task. You wouldn't use a hammer to tighten a screw, and you wouldn't use a screwdriver to loosen a bolt. Similarly, each test is appropriate for different types of data and research questions. T-tests are used to determine if there's a significant difference between the means of two groups. For example, you might use a t-test to compare the test scores of two different classes taught with different methods, or to compare the effectiveness of a new drug to a placebo. The t-test essentially measures the distance between the means of these two distributions, taking into account the variability within each group. The larger the difference between the means and the smaller the variability, the more likely the difference is to be statistically significant. There are different types of t-tests, such as independent samples t-tests and paired samples t-tests, but they all share the same basic principle: comparing the means of two groups. ANOVA, or analysis of variance, is used when you want to compare the means of three or more groups. For example, you might use it to compare the yields of crops treated with different fertilizers, or to compare the performance of different marketing campaigns. ANOVA works by analyzing the variance within each group and the variance between the groups. It calculates an F-statistic, which represents the ratio of between-group variance to within-group variance. A large F-statistic suggests that the means of the groups are significantly different. The null hypothesis in ANOVA is that all the group means are equal. If the F-statistic is large enough, we reject the null hypothesis and conclude that at least one of the group means is different from the others. The chi-square test is different from t-tests in ANOVA. It's used to analyze categorical data and determine if there's a significant association between two categorical variables. For example, you might use a chi-square test to analyze the relationship between gender and voting preference, or to analyze the relationship between education level and whether someone purchases a particular product. The chi-square test compares the observed frequencies in your data to the expected frequencies under the assumption that there's no association between the variables. If the observed frequencies are very different from the expected frequencies, it suggests that there is a statistically significant association. The chi-square statistic measures the difference between the observed and expected frequencies. The test also considers the degrees of freedom, which depend on the size of the contingency table. Let's recap. Use a t-test when you want to compare the means of two groups. Use ANOVA when you want to compare the means of three or more groups. And use a chi-square test when you want to analyze the association between two categorical variables. Remember, choosing the right test depends on the type of data you have and the research question you're trying to answer. Understanding statistical tests is crucial for data analysis and decision-making. We encourage you to explore these tests further and practice applying them to real-world data sets. Thanks for watching.